chose a Scottish cat for my project, and we will first start off with the chromosome and the 3 related loci shown. The first one has to do with hair color, and it's either going to be white or gray, and then the second one has a longer short fur, and then the third one is green or orange as eyes. So for the dominant alleles, we have gray fur, long hair, and orange eyes, and for the recessive alleles, we have white fur, short hair, and green eyes. So I like to look at it like this. So we're going to have gray fur is going to be dominant over white fur, long hair is going to be dominant over short fur hair, and then orange eyes is going to be dominant over green eyes. For our P1 test cross, we bred a homozygous dominant female with a homozygous recessive male to get the results shown here. And so for the F1, we see that the offspring is heterozygous, but we still see the same phenotype as the mother because the mother passed down the dominant alleles. The F1 offspring will have green eyes, have gray hair, long hair, and orange eyes. So taking the results from the F1, we're going to do a test cross with a heterozygous female and a male cat that has 3 genes that we're interested in. So this male cat would be heterozygous recessive male. We do this so we can see the kind of gametes a female produces by test crossing, ensuring that the alleles given by the heterozygous female cat will control the phenotype. There are 8 different phenotypes that are possible for the offspring. Here are the gametes. There are no test cross occurred, and they have more of a chance for looking like their parents because there's less likely chance for a recombination to occur. And so you see that we have gray fur, long fur, orange eyes, and white fur, short hair, and green eyes. Next, we do a double crossover. It is less likely for a double crossover to happen because crossover twice is less likely than having just a single crossover. So this is how the double crossover works. You go here, and then for the phenotype for this, it's going to be either gray fur, short hair, and orange eyes, or white fur, long hair, and green eyes. And there's the genotype. The next we show the possible phenotypes and genotypes for our cross for a single crossover event in region 1. This will be more likely to happen compared to the double crossover because there's just 1 instead of 2 crossovers. So here's the phenotype for these: gray, short, and green, white, long, and orange, and the genotype. And this is how it works. And so here are the results for the single crossover in region 2. We see it's basically the same as 1, but the crossover in the second region. And the phenotypes are gray, long, green, and then white, short, and orange. And then there's the genotypes. So here we have the distance of between the G and the L, the 18.5 centimorgans, and the L and O, 8 centimorgans, and we would have more recombination in region 1 than region 2 because region 1 is 18.5% chance of recombination happening in this region, and for region 2 it's an 8% chance of recombination. So our coefficient of coincidence is 0.8. And so here let's test for the double and single crossover to see the probability of both and how the double crossover will be less likely. So for this we have the probability of the event occurring, and so we put these in decimal form that we have the point and then the here and then that's it, and then the probability of the event occurring for a specific gamete, and you just do the same thing, multiply it by half because you're doing the double crossover, so you cancels it out. So for our single crossover in the equation, this is the equation for that. And then from this, for the specific gamete, it's this, same thing, but just multiplying it by half. And so we can see that it is less likely for our double crossover to happen.